Show that the locus of a moving point such that the difference of its distances from 2 points, one has the coordinates AE, 0 and the other has the coordinates negative AE, 0 is 2a. That is described by this particular equation, and we also have a condition here that b squared equals a squared times e squared minus 1. Okay, let us begin. So here we have, let's say, 2 points. Point A having the coordinates negative AE, 0. We'll consider another point B. B has the coordinates positive AE, 0. Now it's given here that we have a point P. We'll suppose that the point P has the coordinates given by h, k. Then it's given here the difference of its distance. Difference of its distance means we're going to join point A and point P, and we're also going to join point P and point B. Now here it's given that PA minus PB, so that's a constant, and it's given that this is equals to 2 times A. Fine. Now using this particular equation or condition, we can say we have to obtain the locus of the moving point as given by this equation. Okay, let us begin. So first what we'll do, we'll obtain the length of PA by using the distance formula. So we'll take the square root. Underneath the square root we have h plus AE squared added to k minus 0, so that's k squared, minus we have square root of h minus AE. All we are doing is taking the difference of the x coordinate, squaring it, and then adding it to the difference of the y coordinate, k minus 0, and squaring it. This will be equals to 2 times A. Now we have square root of h plus AE whole squared plus k squared. Now what we'll do, we'll transpose the second term to the right hand side. We get 2a added to, we have square root of k squared plus h minus AE whole squared. Now let's square both sides. Squaring both sides is going to get rid of the square root on the left hand side. Now we have h plus AE whole squared plus k squared equals to, now here we have two terms. 2a is the first term and the second term is the one that involves the square root. So when we square it, we'll have to apply a plus b whole squared identity. That's going to give us, so 2a whole squared is going to give us 4a squared. This will be added to square of the square root term, so that takes care of the square root. So we have k squared plus h minus AE whole squared. Then we have plus 2 times 2a, so that's going to be 4a, and this will be multiplied to the square root of k squared plus h minus AE whole squared. Now we can cancel out k squared from both sides. What we'll do, we'll transpose this particular h minus AE whole squared from the right hand side to the left hand side. So we get h plus AE whole squared minus h minus AE whole squared. So this will be equals to 4a squared plus 4a multiplied to the square root of k squared plus h minus AE whole square. Fine. So let's square it. We get h squared plus 4aEh plus a squared e squared. Then we're going to square h minus a first and also subtract it from the expansion of h plus a whole square. So we're going to get negative h squared plus 2aEh minus a squared e squared. So be very diligent while performing the calculation whenever a negative sign is involved. And on the right hand side we have 4a squared plus 4a multiplied to the square root of k squared plus h minus AE whole squared. Fine. Now we can do some cancel out here. H squared and negative h squared, positive a squared e squared and negative a squared e squared gets cancelled out. So now we are left with 4 times a times e times h on the left hand side, and on the right hand side we have two terms, but from the two terms if we take 4a as the common factor, that means we'll now have a plus square root of k squared plus h minus AE whole square. We can factor out 4a from both sides. Now we have EH equals to a plus square root of k squared plus h minus AE whole squared. We'll transpose this a to the left hand side. That gives us e times h minus a, and this will be equals to square root of k squared plus h minus AE whole squared. Now let's do one thing. Let's get rid of the square root on the right hand side by squaring both sides. We get EH minus A whole squared. So this will be equals to, we have K squared plus H minus AE whole squared. Let's expand EH minus A whole squared. We get E squared H squared minus 2EH times A plus A squared. So this will be equals to, we have K squared added to H squared minus 2AEH plus EA squared, E squared. Fine. So here we can cancel out negative 2AEH from both sides. So now we have E squared H squared plus A squared. This will be equals to K squared plus H squared plus A squared, E squared. So let's do one thing. We're going to rearrange the terms. So we have K squared plus H squared, and we will transpose this E squared H squared to the other side and combine with H squared. So we have negative E squared H squared. And on the right hand side, now we will have A squared minus A squared E squared. Fine. Let's do one thing. We get K squared. Now from the second and the third term, if we take H squared as the common factor, this will be multiplied with 1 minus E squared. Whereas on the right hand side, if we take A squared as the common factor, this will get multiplied with 1 minus E squared. Now, in the problem itself, it was given that there is a relationship B squared equals A squared times E squared minus 1. Let's write it down. We were given that B squared equals A squared times E squared minus 1. However, we have 1 minus E squared here. Let's take care of that. We take K squared. So we'll take negative as the common factor. Now we have H squared multiplied to E squared minus 1. That will be equals to negative A squared times E squared minus 1. So what we can do? We can replace A squared times E squared minus 1 with B squared on the right hand side, whereas we have a E squared minus 1 on the left hand side. So this can be also expressed as, let's say, if we isolate E squared minus 1, this will be the ratio B squared to that of A squared. So let's substitute all the required values. So we have K squared minus H squared times B squared over A squared. That will be equals to negative B squared. Fine. So now we'll divide each terms with B squared. So let's divide with negative B squared. So we have negative K squared over B squared. So this negative will now become positive. So we have H squared over A squared. Because this B squared will get factored out with the B squared that we have divided. And this will be equals to 1. Or if we rearranged it, we get H squared over A squared minus K squared over B squared equals to 1. So we are almost done. We have to do one final replacement here. So we will replace the value of X with, it's the other way around. We're going to replace the value of H with X and the value of K with Y. Then our equation of the locus will become X squared over A squared minus Y squared over B squared equals to 1. And we have successfully showed that this is what we needed to show, that the locus of that point is given by this expression X squared over A squared minus Y squared over B squared equals to 1. Hence proved.